Hi guys, so I'm following up on my next video and today we will talk about structures. We have already covered variable declarations and then arrays. Next is mixing of those two things and kind of a grouping. So that's what we have structures for. This is a heavily used C construct. So we will look at the disassembly and the memory analysis of that. So this is how you define a structure. This is the compatible way between C and C++, although sometimes you will have struct, then struct name and stuff like that, but this is very neat. Also, if you have the other one which looks like struct and struct name, so you have to have struct all the time, but this looks very clean, like the type def approach. This is the industry standard to have this approach. Also, it is used in Windows as well as Linux. So we have two members over here and 10 and 20. This is not the ideal way to use a structure, but since we have not covered pointers, we'll cover that in the next video. And I have to trace back from what's the use of a pointer and start from the same thing, using it with a variable, using it with an array, then finally structure, so that everything is streamlined. I do not want to introduce pointers just for the sake of it. If there is no need of a pointer, why the hell even put that there? Anyway, so this is how a structure looks like, and we have some members initialized over there. It's a normal C construct, nothing fancy over there. I'm not doing any printf statements because that would be part of functions. So unless functions start, I wouldn't introduce printf statement, not even hello world. So I expect you guys to be good in C, and I hope you would have already seen my assembly videos. So for us there is no need of that. So it's just default Visual Studio project, in that this is a kind of a C subset of C++. So we would be using the C++ compiler here. It doesn't make any difference, so that's why I use this thing. Okay, so let's build it. So I have already built, so that's why no errors there. And then we will open up Windbg. Reversing structures, debug, this one. Okay. So we will go through the same process. Load modules. So here our main function is main itself, but the image path, image name is structures. So we will set a breakpoint bp structur structures, and then main. It downloaded the symbols. So if we do lm, so now the pdb symbols are set. Symbols are very important, otherwise we wouldn't be able to see any kind of the method names later on, but now how the structure looks like in memory, we wouldn't be able to find that also. It would be extremely difficult, but there is a way how to do that, so we will cover that much later in advanced reversing course, not now. While we are checking how the vulnerabilities work, that time we will cover that, because the closed source programs usually do not have debug symbols, so how someone is going to find vulnerabilities there, we'll check that. Okay, so here is something new, how this thing came up. It's because of when we open up a file, Visual Studio compiled file. So because Visual Studio and Windbg all are from Microsoft, so it automatically picks up where the source file is. I didn't have to do anything, just provide the debug build and it will automatically pick up the source file. It's very, very simple. And also since we are advancing with Windows debugging, so we should start developing our applications in Visual Studio, and we do not have to do that in the command line. So I personally do not like command line, because so many typings and all those bullshit, so I do not like that. And also you will feel good writing code in a debugger because you are not developing for a 8-bit microcontroller, even though 8-bit microcontroller also, those development also can be done in Visual Studio. So you feel good, you write good code and you debug well. So that's my view is that's what I feel. Okay, so we have hit the breakpoint. We are at main function. So this thing, by the way, this is just it's there in the memory. Actually it's there, but it's in BSS section. Now the PE file, it has many sections. The text section is also called as segment. Both are same thing. So the PE file, the exe file, it has BSS section, uninitialized data, then text segment or text section, so many things. So right now that thing is in the BSS, uninitialized data, because it's not initialized. We are going to initialize over here. So we will not find it in the text segment. Like this kind of assembly instruction, we will not be able to find that. So in order to get to that, we have to execute some instructions. So we go to the next line. So we are here. Now it's very easy to see, right? Like how simple it is to see that in the in the debugger in the form of C program. But we want the assembly as well. So let's do that. I will dock it. Okay, so it's docked. Now you just saw that we were here and now suddenly we are here. So many assembly instructions get executed just for executing few lines of C code that we have already seen in while we were developing the compiling the program in the command line. So we have already seen that in the text editor. So this is nothing new, we already know this. So what I want to show you is the structure analysis in Windbg. So the command for that is dt, and then I can type md. So when I do md, local var it means local variable at this address. So this is the thing that is used for that's the Windbg command. It can display information about structures and unions, global variables and local variables, stuff like that. So it's a local variable now. So this thing. So if we go to this location, let's go to that. So we see that these are all some uninitialized data, because always there is something hanging around in the memory. So many things are going on. The virtual memory puts things and then swaps it, cleans it up, so many things. So right now the process has committed this memory to us, so this is ours and we are going to use it. Okay, I will make up some real estate so that we can see clearly. And now I'm going to step through. So the primary debugging commands are step into, it means getting inside any function, step over means skip over, or step out. I'm going to execute the next instruction, step into. So let's do that. So as soon as I do that, if we check the memory analysis at this thing, so it looks like CCC. So let's go back, up arrow key, and if we go to the memory location, so now what we have is 0A. So we have already talked about this. Intel is little Indian, so the least significant byte would be stored first, and so on. So this is the higher memory, this is going towards low. So the least significant byte is stored first, that's why we have 10 over there. If we had like 1010, like 1010, so it would be 0A0A, it would be like that. So this 4 bytes, integer is 4 bytes, it's already taken. It's already taken. Now we can see over there in the disassembly. So dword PTR, we have already talked about this. Dword PTR means casting. Dword is 4 bytes. So that's why this guy took all the 4 bytes. So that means after executing this instruction, this thing is going to be nulled out. And probably here, because Intel is Little Indian, so this will be filled first. And then we will have all these as 0. So let's see that. So we executed that thing, and up arrow key we go back to the same memory location. So we have over there as well. So if it was 2020, so it would be 1414, so and so on. So that's all I have for you now, and I just wanted to give you some little analysis, like how do we do the structure analysis. So what I am doing is I'm trying to making you familiar with how C looks like in assembly. As you saw that today's assembly code, it was a little bit complicated. So the complexity will increase, but we do not have to focus on all the parts like least effective address, stos, rep, all these instructions. So this is how means you get something every time. Like our complexity of the tutorials will increase, and we will talk about all these instruction. I'm not giving much details for now. I just wanted to show you just only how the structure looks in memory, that much only. And we will further make more videos on specific these instructions later on. So because that would be Intel specific tutorials rather than how the program is behaving. So I will see you in the next video, and in the next video we'll talk about pointers. I will quickly wrap up that with the variables, arrays, as well as structures. I'll try to sum up all three, or I may make separate videos as well. I think just explaining one concept, it takes 10 to 15 minutes. So I guess I would make separate videos. I want to quickly get into the common weakness enumeration thing. So but these are the basics also, and we can't skip them. So we'll cover the basics, and then we will jump into common weakness enumeration, the real meat of reverse engineering, that what we are doing. So I will catch you guys in the next video. Hope you like this video. Please subscribe, that would encourage me, and post your comments, and I may, if I find something that I'm missing something, I will improve on that as well. Have a good day. Bye bye.